In the 19th century office, every archival record required a human clerk, known as a scrivener, to write it out by hand. As railroads and corporations expanded during the Second Industrial Revolution, they began generating mountains of paperwork. Yet the internal workflow for processing that data hadn't evolved since the Middle Ages. Professional print shops existed for massive jobs, but they were too expensive and slow for a daily office memo. If a manager needed 20 copies of a letter, they had to pay 20 men to sit at slanted desks and mimic the original, line by line. Long before lasers or digital scanners, breaking this bottleneck meant getting creative with the raw materials already sitting on the desk. Inventors began looking for ways to exploit physics and messy chemistry to trick paper into duplicating itself. The pressure of this paper-heavy economy forced inventors to find mechanical workarounds that could bypass the scrivener's hand and turn the office into a center for manufacturing information. In 1780, steam engine pioneer James Watt introduced the first major attempt to automate the process, the letter copying press. A clerk would write a document using a special ink, intentionally leaving it unblotted. They then covered the page with a damp piece of thin tissue and a layer of oiled paper before crushing the whole stack inside a heavy iron press. Under pressure, the thin, damp tissue absorbs the wet ink, migrating upward through the fiber to be read from the front. But since this relies on physical transfer, each press depletes the master. A second attempt yields only a faint shadow. Despite that limit, these presses became an essential security tool for men like Thomas Jefferson and George Washington, who used portable models to ensure they always kept an exact copy of their outgoing mail. The wet press was a perfect solution for archival records, but it offered no way to produce a batch of copies for wide distribution. For mid-range needs, batches of about 50 copies, offices eventually moved away from heavy iron and toward the chemistry of the hectograph. The process traded standard ink for a heavily concentrated aniline dye. A clerk would write out a single master document, literally loading the page with a reservoir of color. That master is pressed face down into a tray of firm gelatin. The gelatin acts as a chemical sponge, absorbing the dense dye and holding a perfect mirrored impression of the text on its surface. When blank pages are pressed against the loaded gelatin, the dye migrates again, pulling a thin layer of color onto the new sheet. This continues until the dye in the gelatin is finally exhausted. This process required no expensive machinery, only a pan of gelatin and a bottle of dye. It meant that for the first time, schools, small churches, and community groups could produce their own newsletters without hiring a professional printer. To reach industrial speeds, producing thousands of duplicates at a time, the office required a technology that didn't rely on the transfer of ink, but on the management of holes. Thomas Edison's solution was the electric pen, a motorized device designed to turn a piece of wax paper into a durable printing stencil. Powered by a wet acid battery, a motor drives a needle up and down, punching 100 microscopic holes per second through the wax. As the clerk writes, they are essentially creating a physical map of the letters. That wax stencil is then wrapped around a drum. When a roller passes over it, ink is physically forced through the microscopic perforations, depositing the text onto blank paper fed through the machine. This design evolved into the massive rotary mammographs that eventually dominated corporate spaces, allowing a single operator to churn out thousands of crisp, identical copies. By turning a master document into a physical screen, the stencil finally broke the bottleneck, giving every desk the production capacity of a small factory. For nearly a century, these mechanical workarounds served as the primary link between the era of the quill and the age of the computer. They remained the standard for offices until Chester Carlson's invention of xerography, which used static electricity and dry powder to eliminate the need for gelatin pads and vibrating needles. Before these machines, reaching 1,000 people required the capital to hire a professional print shop. By making duplication cheap and local, these devices shifted the ownership of information. They allowed science fiction fans to publish the first fanzines, political dissidents to circulate underground resistance pamphlets, and teachers to design their own curricula without a central authority's oversight. By finding ways to bleed ink through tissue or punch holes in wax, these inventors moved the power of the press out of the factory and onto the corner of a desk.